What subject is so important that it's talked about nearly every day by just about everyone? Here are some hints. Every day it's written about on the front page of most newspapers. Sometimes people travel thousands of miles to experience it. At times, it can cause tremendous damage to property and even slow traffic, making it difficult for people to travel to their destinations. What is this phenomena? If you said weather, you're right. Weather affects our lives every day, having the ability to shut down schools, bring cars to a standstill, and provide just the right conditions for certain kinds of sports. During the next few minutes, we're going to explore the nature of weather and some of the ways we monitor weather. When you woke up this morning, one of the first things you probably did was to look outside to see what the weather was like. What is weather? Weather is the daily condition of the Earth's atmosphere. In some places, the weather changes are abrupt and frequent, while in other places, the weather is relatively stable day to day. What is responsible for differences in weather? And which factors influence weather? What variables in the atmosphere interact to cause weather? There are several main factors that interact to affect weather, including heat, air pressure, wind, and moisture. Let's take a look at how heat interacts with the atmosphere to affect weather. The sun is our nearest star and the source of heat for our planet. When you feel the warmth of the sun, you're bombarded with a type of energy called radiant energy. Radiant energy is extremely important in that it warms the earth and enables plants, animals, and humans to carry out life functions. Fortunately for us and living things, not all the radiant energy from the sun actually reaches the surface of the earth. A great deal of the sun's energy is actually absorbed, scattered, or reflected by the atmosphere. Water droplets and dust particles in the atmosphere can absorb or scatter radiant energy from the sun. A thin layer of gas called the ozone layer plays a crucial role in absorbing a type of radiant energy called ultraviolet radiation. You've probably heard of the ozone layer because it's believed to be deteriorating due to pollutants in the atmosphere. The blue area in this image over Antarctica represents a large hole in the ozone layer. Ozone is very important in absorbing ultraviolet radiation. Damage to the ozone layer could increase the amount of ultraviolet radiation hitting the Earth, causing damage to plants, animals, and even humans. Clouds also play a role in absorbing and reflecting radiant energy. The radiant energy that does reach the Earth's surface can also be scattered or absorbed. Ice, snow, land, and water can reflect radiant energy. The radiant energy that is absorbed by the atmosphere or land can be distributed or spread through the atmosphere in different ways. Let's take a look at some of these ways. This silver spoon has been in this boiling water for 15 minutes. You decide. Do you think this end of the spoon is hot or cold? It's very hot. How did this end get hot, even though it's not in the boiling water? Heat traveled up the spoon via the process of conduction. Conduction is the direct transfer of heat from one substance to the other. This red-hot steel is transferring heat to the tongs and wheel on the right. In the atmosphere, cooler air coming into contact with the warmer ground is often heated. Convection is another way heat is transferred in gases or liquids. The heat from this wood fire is slowly spreading throughout this cool room. This is an example of convection. Similarly, heat is distributed through the atmosphere from warm areas to cooler areas. For example, this hawk, seen here in the Arizona desert, is riding a convection current created by rising warm air. Another way heat is distributed is via radiation. Radiation is the transfer of energy via waves. We receive radiant energy from the sun. Energy from the sun is the source of heat on Earth. Without the sun, the Earth would be dark and cold. You walk outside on a cold morning, and you can feel that the temperature is cold. What is temperature? Temperature is a relative measurement of the heat of an object. Temperature is commonly used to measure the heat of air. You decide. How is temperature measured? Temperature is measured with an instrument called a thermometer. Most traditional thermometers consist of a thin glass tube with a bulb at one end, which is filled with a liquid which is sensitive to changes in temperature. When the temperature rises, the liquid expands and rises. And when the liquid cools, it contracts and falls. Thermometers can also be digital, relying on electronics to operate. Temperature is measured in degrees. In most of the world, and in science, the Celsius scale is used to measure temperature in the metric system. The unit of temperature on the Celsius scale is the degrees Celsius. Water melts and freezes at 0 degrees Celsius. And 100 degrees Celsius is the temperature at which water boils. Temperature is an important factor which influences the type of weather we experience. Next time you go outside, look straight up at the sky. Above you is hundreds of kilometers of air which is pushing down on your head. The force of this air pushing downward is referred to as air pressure. Air pressure depends upon the density, temperature, and amount of moisture in air at any given point on the Earth's surface. Air pressure varies day to day and from place to place. Generally speaking, warmer air is less dense than cooler air. Therefore, warmer air tends to exert less pressure than cooler air. Moisture-laden air also tends to be less dense than dry air, thus exerting less air pressure. And as elevation increases, or you go up in altitude, the air becomes thinner or less dense.
Developing low pressure over the Gulf Coast will...
On the radio, you hear the weather forecasters say a major low-pressure system is headed our way. What does this mean? And how is air pressure measured? A low-pressure system, seen here, consists of a large body of air which has a lower pressure than surrounding air and often produces precipitation, rain, snow, or sleet. You decide. What instrument is used to measure air pressure? Air pressure is measured with an instrument called a barometer. This is a common type of barometer called an aneroid barometer. An aneroid barometer consists of an airtight chamber. A change in air pressure causes a needle to indicate the air pressure. Barometers help forecast the weather by monitoring changes in air pressure. Higher air pressure generally means fair weather is predicted, whereas low air pressure tends to signify cloudy and perhaps stormy weather. What is keeping this kite aloft? Wind. We've all felt the wind and seen the effect of wind moving objects. But what causes wind? Wind is generated by horizontal differences in air pressure. So, it can be said that air moving from areas of high pressure to areas of low pressure produces wind. Different parts of the Earth heat at different rates. You decide. What part of the Earth do you think receives the most amount of heat throughout the year? The area near the equator receives the greatest amount of heat, and the polar regions receive smaller amounts of heat throughout the year. At the equator, warmer air rises and moves toward the poles, and at the poles, cooler air sinks and moves toward the equator. These differences are fundamental in the creation of global winds. But winds do not move directly from north to south or from south to north. This is because the Earth is spinning. The spinning of the Earth causes winds to bend to the right in the northern hemisphere and to the left in the southern hemisphere. The curving of wind direction is called the Coriolis effect. While wind patterns can be formed on a global level, they can also be formed on a local level. For example, notice the direction of wind on this beach at midday. You decide. In what direction is the wind blowing? The wind is blowing from the ocean toward the land. This is called a sea breeze. Sea breezes can be formed when cooler ocean air replaces warm air over the land, which rises. At night, the breeze reverses. The air over the ocean is now warmer because the land surface cools off quickly. The warm air over the water rises and is replaced by the cooler air from the land, creating what is called land breeze. These are just a couple examples of local winds. Have you ever noticed moisture on the grass early in the morning, even though it didn't rain during the night? Where did the moisture come from? It came from the air. As the air temperature dropped, the moisture condensed on the vegetation, forming dew. Moisture or water vapor in the air is called humidity. You've probably heard people say it's a humid day. Sometimes you can feel the humidity in the air, particularly on a hot and humid day, or on a cold, damp day. Water vapor in the air is a very important factor in the creation of weather, especially when it comes to the creation of rain or snow. During the past few minutes, we've learned how weather affects our daily lives. And we've taken a look at the factors which interact to create weather, including heat from the sun, and the means by which heat is distributed through the atmosphere via conduction, convection, and radiation. We also took a look at the role air pressure plays in affecting weather, and how air pressure is measured. We saw how wind is created both globally and locally. And we discuss the importance of moisture in the development of weather. So, the next time you look out the window, think about some of the factors which affect weather. You might just think about weather a little differently. Fill in the correct word when you hear this tone. Good luck, and let's get started. Number 1. The is the source of heat on Earth. Number 2. Energy from the sun is absorbed, scattered, or Number 3. The layer absorbs ultraviolet radiation. Number 4. Is the direct transfer of heat via contact. Number 5. Is the transfer of heat via waves. Number 6. Moisture-laden air is dense than dry air. Number 7. An instrument called a measures air pressure. Number 8. Wind moves from areas of pressure to areas of low pressure. Number 9. A breeze blows from the ocean to the land during the daytime. And number 10 is a measure of water vapor in the air.